Good morning everyone. My name is Gagan Preet Kaur and presently I am teaching Operation Research, which is an open elective in every branch of BTech final year. My today topic is game theory. Game theory, as the name suggests, is related with the payoff matrix, which is formed with the help of what is losses and what are the gain with each and every player in the game, and where we can find out the saddle point between the first player and the second player. It was basically, you can say, a concept of von Neumann and Morgenstern, which were the father of games theory. Today I will cover these two topics: game strategy and components of game. There are many types of game. For example, this is two-person game. In two-person game, each person knows own and opponent alternatives. For example, like chess, carom board, table tennis. So here we have two players and we know each and every player. All preferences are known. It is a single period game. That means both are playing at the same time. Sum of payoff is 0. Equilibrium reached when neither of the participant can improve the payoff. If the participant cannot improve the payoff, then we can say that saddle point has been achieved. Games theory can be solved with these two methods. One is dominant strategy, which is to have the best strategy in case of both the player, and the second is maximum strategy. Unstable games are the games, we also call them mixed strategy games. These games actually have no equilibrium, and we have to use dominant strategy to find out the solution to each and every game. For example, I am taking this example of a games theory. First, we have to find out the equilibrium point that is our saddle point. Now, saddle point, for example, this is player A and this is player B, and this is known as the payoff matrix. Payoff matrix means when it is a positive 4, that means it is the gain of player A and loss of player B. When there is a negative term like here, like -5, that means it is a profit of player A and loss of player B. So both the profit and losses of these players can be represented by this payoff matrix. So before solving the value for the value of game, what is the value where we can find out the equilibrium, we have to find the saddle point for this particular game. For example, what we have to do, we have to find out the minimum of row and maximum of column. Now, in this row, the minimum is 0. Here it is 1. Here it is -5, -1, -2. Similarly, we will find out the maximum of each column. This is 4. Here it is 3, 7, 3, 2, 2. So this criteria here, in case of A, we have to find out maximin. That means we have to find out maximum from the minimum. So here in this minimum numbers, 1 is the maximum point. So it is a maximin point. In this case, we have to find out minimax. So these are the maximum point and we have to find out the minimum in it. The minimum number is 2. It can be either of this. You can take this. This is known as minimax. If the value of maximin point is equal to minimax point, we can say that equilibrium has been achieved and we cannot improve the solution to this game. But if they are not equal, that means like in this case, both of the numbers are not equal. So what will happen? We have not achieved the equilibrium. So we have to find the value of game where each opponent can use that strategy to go to the equilibrium. So here it is the case of mixed strategy. So we have to use the dominance method to solve this problem. I will rub all this. Now what is the dominance column? In dominance strategy, there are 2 rules which you have to follow. Since equilibrium has not been achieved, so we will use some other strategy to find the value of game. So this is player B. Now dominance. With the help of dominance method, we will eliminate the rows and columns which can be dominated or which can dominate. So here the rule for row is like this. In row, what we have to do is, if the particular row is dominated by for example, it is dominated by some particular row. For example, in this case, we will take the example like sorry, in this 2 and 3 row, for example, 2 row is dominated by, for example, you can see 4 is equal to 4, 3 is equal to 3, 4 is equal to 1, minus 1, 3, 2, 2 and 2 and 2. We have to compare 2 rows. If, for example, this row is dominating this row, the second row is dominating third row, sorry, and so the row which has been dominated will be deleted. Now in this case, we can see 4, 3, 3 minus 2, 2, 2. So here we can see 4, 4, 3, 3, 1, 3, 3 minus 2 and 2, 2, 2 and 2. So what we will do, we will see row 2 and row 5 is dominated by row 4. So row this 2 and 5 will be deleted. The which is, you can say, minimum row will be deleted. So we will have another row. Okay. So deleted rows will be, one is this one, this is deleted and this is deleted. So these 3 rows are left. Now we will compare between the columns. In column we can see column 1 and 2 are dominated by the column 4. Here you can see column 1 and 2 are dominated by column 4. Here you can see 4, 3, 4, minus 5, 4, minus 1. So this one is a bigger one, this one is a smaller one, and 4, and so what will happen? We will delete this column. What happens actually? In rows, we delete the minimum one, and in column we delete the maximum one. So this column is deleted. Next, the column which is deleted is this one. Since it is also dominated, 3, 3, 3 minus 5, 3. So you can see that column 4 is also dominating this column. So the bigger column will be deleted. Now we have this 1, these numbers are left 1, 7, 5, 4, 3, minus 5, minus 1, 2, 1 and 2. Now what we will do, we will again see if there is any case where we can use dominance. So in rows we will see 7, 1, minus 5, 3. Each and every element should be lesser than or greater than the other element of row or column. Now here we will see 1, 7 is greater, but 1 here minus 5 is creating problem. Now we will see these row 7, 4, minus 5, minus 1. So it is smaller one. So in rows I think dominance is not possible. So we will look into the column thing. Here we will see 1, 3, 7, minus 5, not possible. 3, 2, minus 1, minus 2. So there is not a single row or column which can be dominated or which can dominate. So what we will do? We will use the average rule to solve this problem. Now what is the average rule? We will find out the average of two elements and see whether their average is dominating the other column or row or not. In this case, for example, this is 3 plus 1 divided by 2, 7 minus 5, 4 minus 1. So it comes out to be 2, 1 and 1.5. Now this is 2 is 2, 1, 1, 1.5, 2. What we do in column, if you remember, we eliminate the bigger column. So what will happen over here? We will delete this column. Now it will be reduced to this. Now again we have to find whether any dominance can be, since we have to make it a 2 by 2 matrix. So average rule in rows will be followed now. Column are 2 but rows are 3 over here. So we have to reach 2 rows over here. So what will happen? In rows what we have to do? The smaller one is eliminated. So 7 plus 4, 11 by 2 minus 6 by 2. So this comes out to be, it is 5.5 and minus 3. It cannot be dominated. So we will see another average rule which can be followed. So 7 plus 1, 8, 4, and this is minus 2, 1. 4, 4, minus 1, minus 1. So average has been reached. So we can eliminate this row. So now I have to rub this. what will happen? Now we have a 2 by 2 row and element with us. You can see we have a 2 by 2 matrix with us. So what will happen now? We will find out the value of game where the equilibrium can be reached. It is 1, 3, 7, minus 5. One thing more, since these are all strategies of player 1, so we have to write down which strategy, for example, this is A, B, C, D, E, F, which strategy is left behind. For example, 1 and 3. 1 and 3 come over here. So this is C and D, and 1 and 7. So this is 2 and 3. These are the strategies which will help us to achieve the value of game. Now, what we will use? We will use oddment rule to solve this problem. Now, what is oddment rule? To solve this 2 by 2 matrix and have the value of game, we have to use oddment rule. Oddment rule states that we have to add both these. For example, this, I will take this 1, 3, 7, minus 5. Here we have to add these two, and for example like this, ignoring the sign. For example, 1 plus 3 is 4. So divided 1 plus 3 is 1 minus 3 is, oddment rule state that we have to subtract these two. So it will come out to be 1 minus 3 modulus, and this will be 7 minus 5 minus 5. So here we will write down 12, and here it will come 2. Similarly, in this case, 1 minus 7 is minus 6, minus 3, sorry, no sign, it is the modulus. 1 minus 7 modulus is 6, and this is 3 minus minus, it is 8. So these are the oddments. Now, like we do in a ratio, if you remember, what will be the ratio? If this strategy is selected, then it is 12 by 14, 2 by 14, 8 by 14, and 6 by 14. So these are the value of optimum strategies, the proportion in which if they will be selected, so we will achieve the you can say equilibrium by selecting these proportion of strategies. So here we have, this is 6 upon 7, 1 upon 7, this is 4 upon 7, and 3 upon 7. These are the optimum value of strategy. So for A, we have strategies. For this A, we have 0, since it is second and third one, 6 by 7, 1 by 7, 0 and 0. This is the optimum strategy. If it is played by A, then we will have the equilibrium. So for B, it will be C and D. So A is 0, B is 0, C is 4 by 7, 3 by 7, and this one is 0. So here we have the optimum strategies for A and B. Next thing is to find out what is the value of game. To find out the value of game, what we will be doing, value of game can be find out like this. 1 into, we have to multiply the oddment with 1 into 8 plus 3 into 6 upon 8 plus 6, that is equal to 8 plus 18, 26 upon 14. So value of game is 13 by 7. This is the value of game. This is one of the methods. I have told you two methods, maximum and minimax method, to find out the equilibrium point. Second method is our dominance method to find out the your value of game as well as the optimum strategies which can help us to reach the you can say a stable point. While doing this, there I want to share one more case. Let me rub this. There is one more method which help us to, for example, generate the value of game, that is known as the graphical method. Graphical method is applicable to only 2 by m or n by 2 games. That means either rows or column have to be of two sides. Okay. So in graphical method, since we have only x and y axis, in graphical method, why we use graphical method? Since you have seen at some point of time we don't have any comparison left between the rows and the column. So what we do, we actually use average rule. Sometimes it happens average rule is not applicable to such kind of problem. Then what happens? For example, I will take one example and illustrate that example to you. For example, it is a 2 by n or n by 2 game. 5 by 8, 5 minus 4, 0 minus 1, minus 1 6 and 8 minus 5. Here you will see it is as I told you, it is 2 by 5 game, that is 2 by m game. Here what we will do, we will use average rule to we will try to use average rule so that dominance can happen, but if it is not possible, then graphical rule is used. Now here we can see, we can compare minus 5 5, 8 minus 4, you can compare all these things, and then after that you will use the average rule. So in this case average rule also fails. Then what we will do, we have to generate the solution, we have to find out the optimal strategy for both the players. So what we should do, then graphical method came into being. In graphical method, what we will do, this is A, this is B, this is 1 and this is 2, this is 1 2 3, these are the strategies. Now we will plot these whole points on a graph like this. Here graphical method is done by this. This is 0 0 reference. Next is, this is whichever axis is 2, A1 and A2. You can see minus is also there. So we will plot all the points over here. Maximum is 8 in A2. 1 2 3 4 5 6 7 and 8, and A1 maximum is also again 8. 1 2 3 4 5 6 7 8. Similarly in negative we have minimum is minus 5, minus 1, minus 2, 3, 4 and 5. Here also 1, 2, 3, 4 and 5. Now we will plot these points on the graph. For example, A1 is minus 5 and this is 8. I will tell you one more thing while doing this problem. A2 is 5, A1 is 5 and minus 4. 0, -1 and -1 and 6. Okay, sorry, ulta ho gaya ye. This will be -1 and 6. Let me rub this. Ouch. -1 and 6. Okay, 8 and 5 minus. This is 8 and this is -5. Now we have plotted all the lines. So what will happen, since it is A's game. So in A game, what we selected, if you remember, maximin. And in B game, we selected minimax. So we have to find out the maximum value in the minimum region. Here, this is the minimum region. Okay, this is the, I can take this. This is the minimum region. If it would be B, then we would have taken this. This will be the maximum region. We will take the minimum point. And this is the minimum region. We will take the maximum point. After that, the two lines which is creating the maximum point will be considered for further evaluation. Like in this case, we will have 1, 5, 1 minus 5, sorry, we will have, for example, I take this 0, -1 and the other line will be this 8 minus 5. So we have 2 by 2 matrix available with us. Now what we will do, again we will find out the different optimum strategies for A and B with the help of oddment rule, and after that we will find out the value of game. So I have covered today 2 topics. One was dominance and one was graphical, which has their own limitations. Now you have to see through it whichever method will be applicable to a particular problem. Thank you very much. In case of any queries, you can contact me personally or you can mail me regarding that. Thank you. Jai Hind.